All right, welcome back to another EquatIO Explore Math Monday. So again, my name is Louis Shanafelt, joined by Ryan Graham, and we are thrilled to be back. We had a little bit of a hiatus there with the end of the school year and students working with exams and Memorial Day weekend, so lots of different interruptions there. But with that being said, we're excited to be back here today with you. It's June 1st. It's crazy, Ryan, that it's already June 1st and it's like technically this summer. But we still have lots of things. Like we're 12-month employees here. So we're going to continue to work really hard on this product to make sure it's in, top condition when you all return back to school. So some things we wanted to cover today is kind of our STEM tools. We were really, really thrilled last week to push out our STEM tools button on the EquatIO extension toolbar. And with that, I am going to go ahead and kind of jump right into our first topic. And that is going to be that I am going to show some chemistry prediction along with some isotopes. And I provided an example here about how we can show, the yielding with heat or with light. So let's jump right in here and show how EquatIO kind of works across multiple platforms, or we should say content areas, because I often make the mistake, Ryan, of saying, hey, EquatIO, this great math tool, but really it's that STEM tool. And that's what we're excited to show you today, how you can use this in multiple content areas. So with that being said, what I decided to do here is to kind of show you how we can use EquatIO to make isotopes. Now, isotopes, of course, are commonly used in science classrooms. And isotopes, of course, are atoms, the same number of protons, but have that different number of neutrons. So how do we make isotopes in EquatIO? Because this is not something that's easy to make in other math editors. So what we've done, or what I've done here, is I prepared this chart. And what I want to do is insert 3 isotopes into this chart. So let's say, for example, you teach science, you're in a STEM content area, and you provide this chart, and you want students to create that isotope. How do I do that? So notice here I have a Google Doc open with my table already preset, and I'm going to insert 3 EquatIO images here. So notice right here we have this fantastic new button. So Ryan's going to dig into that, but first I'm going to jump into the chemistry. So take a look here. We have that periodic table and scientific calculator, which we will show you in just a second. So let's go into isotopes. So the best way to make your isotopes is to jump over to the equation editor. And I would go ahead and click on the equation editor. And the first thing you need to know is, how do I find and locate isotopes? One thing I probably should add, Ryan, into our backlog here is if a user is trying to make an isotope, notice when we type in ISO. So this is why users have sometimes reached out and said, how do I make an isotope? Well, in our prediction, we put it under something called nuclear notation. Well, it was here, Ryan. Where is it? So nuclear notation. Do you know where it's at?
You could probably try in the more icon there and do a little search.
Yeah, let me try here and go to where? Layout?
Layout or symbols, yep.
Yeah, so let's go here and see if we have it here, because I used to locate it in the prediction under nuclear notation. So that's a little strange there. Let me try under formulas. Let me go right back here. You able to locate it on your side?
No, I can't find it like that either.
That's strange, right?
Yeah.
Well, can you get the LaTeX for me?
The dangers of doing of live streaming.
That's right. That's right. So what we typically can do here for everybody that's kind of on board here is we used to type in nuclear notation. I actually have a video of this. Actually, look at this, Ryan. How ironic is this? Look in the Academy. So I'm actually looking at an Academy article that I wrote. So I'm going to go ahead and click on this.
Yeah, go ahead. Maybe I'll let us know what the secret is.
So when I click on here, actually in the Academy, I mean, we have like 90 articles in the Academy. It's just so ironic that this showed up. So creating isotopes is easier than ever, as long as you can find nuclear notation, as the Academy article suggests. And we have a button here. And notice that when I click on this button, you can see here, and let me maximize this. So we'll get this fixed for you all. That's very blurry. I don't know. It's not streaming as well as it should. But I typed in nuclear notation, And I don't know why. Let me see if I can pull this up and actually get this to stream. Here we go. So take a look here. So if I type in, let me back this up just a tad, as Ryan said, limitation of going live here. So when I click on the equation editor, notice when I type in nuclear notation, you should get that in your prediction to pop up. And here's what's great about this. EquatIO provides those boxes for you to be able to type in your atomic mass and your atomic number. So you'll see here in this video, and we'll get this fixed for you all here. Sorry about that. But you'll see the atomic mass will go up top, which of course is your protons and your neutrons. And then the atomic number can go down below. So you'll see how this kind of repeats itself. So this is how you would insert those nuclear notations. Is there a way we can do this kind of on the fly with LaTeX, Ryan, or not necessarily?
Yeah, I'll try and dig out the LaTeX. That's what I always do with LaTeX.
Okay, so we're gonna jump. Ryan's gonna look for the LaTeX. Why don't I jump down? Let me turn that off. So Ryan's gonna try and locate that LaTeX and zip that over for me. Why don't I run down to the second part of what I was gonna show, which is how do I write a balanced equation for this chemical compound for sunlight? So I am going to attempt here a formula here in chemistry where we can add in a chemical compound easily using EquatIO. So we'll come back to the isotopes as soon as Ryan's able to locate that for me. So let me scroll my Google Doc up. And in order to make photosynthesis and show the sunlight energy, I'm going to type in carbon dioxide, so CAR. And notice right here when I type in CAR, it pulls up carbon dioxide. So we have CO2, and this is going to need a 6 in front of it. So I'm going to jump over here and put 6 CO2, and then we're going to do the plus symbol. So I always do PL. I don't ever, usually use the keyboard symbols. I like to use our predictions, one of the things I love most about the product. And we're going to need 6 waters. So I'm going to type in 6 WATER. So we have the 6 carbon dioxide plus 6 water. And then this is where I'm going to type in, or I like to show this too, Ryan. I like to go over to my more palette as we were looking for the nuclear notation here. I actually have, because if I teach chemistry, I might want this in my favorites. I'm going to yield here with heat, but really I'm going to come up here and actually get rid of this symbol, and I'm going to put in light. Okay, so notice we can allow you to type in something above the symbol. And now I'm going to come back down to the front of my formula, and I'm going to begin to type in what's remaining. So I have carbon, and this is going to be C subscript, oops, let me go back one, C subscript 6. So I have, actually, you know what? I probably could just cheat here. I'm going to do that instead. Let's just go find glucose. So we're looking for glucose, and if I type in glue, GLU, and I hit that, that's going to provide the glucose part of my chemical compound plus, and then I get 6 oxygen. So OXY, and I get 6 O2. So notice how this right here is basically the balanced chemical equation for photosynthesis. And then I can simply insert this. Now, before you insert, remember to put your cursor where you want it to go and select Insert Math. And watch how that EquatIO image can just pop right into your Google Doc. So also, I noticed this too not too long ago, where if you hover over the chemical compound, you can see that alt text behind it. So that speaks to the accessibility piece, again, with EquatIO for those users that need that. So any questions about chemical compounds, feel free to reach out to Ryan and I. We have put, I think there's hundreds. Last time I spoke to Ryan about this, if you type in AL and you're looking for a compound here, all I'm doing is typing in AL, and you can see all the different aluminums, right? If I need something like lead, LEAD, and I want to just pop in an element. So we'll talk about the elements when Ryan shows the periodic table in just a second. Any help with the isotopes there, Ryan, or should we just move?
Yeah, there should be some LaTeX there for you in your private chat.
Okay. So let me look here. Yep. And that is in the StreamYard? Yeah.
Yep.
Yep. Got it. Okay, so Ryan, who is a LaTeX whiz here, this is awesome. So he has provided the LaTeX here, and take a look. Oh, perfect. So look at that. So the LaTeX here, which Ryan sent me privately, is right here. So this is a good example too. If I was to pop in here, and Ryan had said earlier to me, privately, like we can add this then to our favorites. So this is another way, Ryan, we can kind of show off our palette here too. And then I can go ahead and add this in. So if I click here and I type in, let's say I want to just go ahead and name this isotopes. Oops. And I hit that checkbox. Now I have isotopes in my favorites. So we will fix that nuclear notation for you and get that back and working. But in the meantime, if you want to pause this video, go back and rewatch it, you can access that LaTeX that Ryan sent over. So it's right there. I'll leave that there for just a second. So if you need isotopes, there it is. And then what I can now do here is make oxygen 17. So that is super fast there and on the fly, Ryan. I appreciate the help. I am going to now add in the for oxygen 17 is what I was looking for. And on my screen, give me just a second here. I have I'm going to change the chemical compound here to O, and then notice how I can come over here and I can type in this box. So now I might have 17 here and let's say 8 here. And that would enable me to insert the isotope into the table. Okay, so that enables me to make those isotopes and respond. I can come back here to the equation editor and I can add in, again, I need isotopes. So I'm going to go to my favorites and I'm going to change this and make my carbon 12. So I get 12 and I get 6 and I can come back here. Oops, let me click and get rid of TS, type in capital C, and remember, make sure your cursor's in the right place. And I get carbon 12 up top for your atomic mass and 6 for your atomic number. And last but not least is bromine. So bromine is going to be for bromine 79. I'm going to click on favorites, click on isotopes, and bromine, I believe, I did not look this up, but Ryan, I should go look at the periodic table. I'm almost positive it's BR, and I should get here 79, and then this is going to be over 35. So that then can be inserted for the isotope for bromine 79. So that's one way we can insert isotopes and make chemical equations using EquatIO. And Ryan, I've already gone way too long, so I'm sorry. We had that little hiccup, so I want you to take it away and show users how we can do some of those physics word problems, uses of pulleys, and other good stuff that we have queued up for today.
Yep, absolutely. I'm gonna try, Louis. My machine is also doing some weird stuff right now.
Yeah.
Which you can't see, but it's absolutely crazy on my screen. So I'm going to try my best here.
No worries.
I'm technology issues. This just, this proves the point. We shouldn't take 2-week gaps in between shows. We should just do it every week. It's this is karma trying to teach us a lesson.
Right.
And so, can you see my screen?
I can.
Okay, great. So whenever we're trying to do physics problems, so say like word physics problems, I have this example problem here in mathspace. So we have a weight with a mass of 0.5 kilos and a bucket with mass of 0.45 kilos hanging on a fixed pulley to determine the acceleration of the system. So obviously these are word questions, not very engaging for students,
Right.
So mathspace provides a great way of making it a little bit more visual, a little bit more sort of tactile and interactive. So we have these very cool shapes in the bottom of the screen here. So I'm going to click on shapes. We've got your basic shapes, your circle, your squares, but in this little more shapes button, we have got a huge database of very, very useful shapes. So obviously we got your general math manipulatives, you got your spheres, cones, base 10 blocks and 10 scripts, which are great. But for this particular problem, what we're going to do is we're actually going to illustrate the pulley. So I am going to draw a first type of pulley. So we've got the 3 different types depending on where the forces are.
Right.
So I'm going to pick this first pulley. I'm going to click on that and drag that little shape onto my mathspace. And then what I'm going to do is I'm going to add some weights onto the pulley. So go back into our shapes, and I'm just going to pick a trapezoid shape in there as well. but drag that over the top. So let's say that is our 0.55 kilos. We're going to do another trapezoid on the left-hand side for 0.45. And we can probably change the sizes of these as well to illustrate.
Yeah.
You know, one is heavier than the other. So we've got the measurements on the right-hand side. So given M1, it's 0.55 kilos. Given M2, 0.45. So what I'm going to do is I'm going to use these values and label them on the weights themselves. So I'm going to open up my equation editor. And we can type in M underscore or subscript 1 for M1. And we can insert that math then onto the canvas. And then we can drag that down onto the relevant weight. So that one is M1. Back in here. And that's already in there. So I can go left and just change that to be M2. Insert. And so now we've got the word problem as well as the illustration for the problem as well. And we could then send this out to the student using the share icon. But what I'm going to do just before I do that, just recently and amongst all the STEM tool stuff, we've been working really, really hard with mathspace. Obviously, we've got all of our new science technology tools, but we've also added on the left-hand side here, multiple pages. And this is, I genuinely think is going to open up a whole world of possibilities for mathspace users, both teachers and students. Because previously you just had the one working area. And if you run out of space, then you needed to go and create a new mathspace entirely. But now if you've run out of space, you can go and add a new page. I click on this button. And that will create an entirely separate working area for you. So in this instance, what I'm going to do is I'm going to use the first page as my question, and the second page will be the student's response. So, all right, to illustrate that, what I can do is click on this and duplicate this page. My machine is running very slow at the minute. So now I've got page 2, has the exact same details on it as page 1. But what I'm going to do is I'm going to just take out some of these here values here, move the pulley across, and then I'm just going to draw a little box, a rectangle in here. And that will be the student's working area. So I'm just going to change the background color of that, just make sure that's white. And then I'm going to put a little text in to say, show your working. Insert. So now we've got page 1 contains the question. Page 2 contains where you want your student to put their answer in. And now we can then share that out with our students, make a copy, and expect a response as well. So that then just means you get that separation between what's the question, what's the answer, and then hopefully down the line as well, whenever we introduce more features, we'll be able to leave feedback for the student on that individual page as well, and then get that back from them.
Right. Yeah, that's awesome. I was going to ask you what that bar on the left was, Ryan. So really, really awesome to see those multiple pages. And as Ryan said, you know, the multiple paging in mathspace now lives under the same thumbnail versus creating that extra thumbnail that Ryan had indicated was, you know, the common practice for users prior to us releasing that. So all really exciting stuff and really, really good feedback that we've gotten in social media in terms of that multi-page mathspace experience. So we encourage you to check that out. I'm glad Ryan was able to show that during our STEM tools demo here. So the next kind of question here that we wanted to jump into today is our scientific calculator. So I have been assigned and privileged to show you our scientific calculator. One of the things that's pretty great about the scientific calculator is we have, again, partnered with Desmos. So many of you know that our graphing editor tool, you know, when I go and open it, powered by Desmos. And in our initial conversations from a development and product management team and some of the even chief officers at TextHelp, you know, Ryan and his team are so capable and qualified to be able to build their own calculator, right? We could have built our own. But one of the things we wanted to do was, you know, to be able to provide that, you know, unique experience for users where, you know, they see a calculator that they're using in EquatIO, and they're also able to see that on an end of course exam. So I want to show you something here real quick, and I'm going to tell you why we kind of went with, Ryan and his team are real busy, and we could have built that calculator, but we decided to go with Desmos on this. And here's why. Desmos, if you're not familiar with, if you look on their website here and you go to desmos.com/testing, you'll notice that Desmos is on 35 of the 50 states tests. So if you find your state, for example, I'm here in Florida, and when I click, you'll be able to pull up where the Desmos calculator is currently running on the test. So if I wanted to see, oh, it's on the FSA, I can click on it, and it'll pull up the Florida statewide assessment and talk about that Desmos integration. So we thought it would be best, even though, like I said, our team's very capable of building our own calculator, that if we could provide under our STEM tools button our own scientific calculator, but this one, again, powered by Desmos, that students are going to be using this calculator all year within EquatIO, then they'll become accustomed and used to using this throughout the year, and then it won't be new to them on the test at the end of the year. So that's kind of our thinking and logic behind that. Wanted to kind of show you a quick demo of their calculator. If you've never used it, it is now in our product. As you can see, you click on the science beaker here under STEM tools, and the calculator is here. So if I go and type in just some general functions like 78 times, let's say 56, notice the answer will appear right here. I can then hit this button here and make an enter, and it'll provide a second line. What's really cool about this is, I was doing some research on this prior to us integrating, is you can click on the answer key, and when you click on ANS, it's going to pull in the answer from the first line, and then I can now do some other math manipulations here, like I can now subtract, let's say, 2756 from this, and it's going to provide that answer. And then I can bring that in if I want to the next line. So I can hit enter, bring that answer then down. So that's really, really neat there. We have some of our trig functions. We have some of our exponent rules here for superscripts, absolute value. You have a quick and easy access to a pi button. You have fractions here. So all these commonly used items on a scientific calculator are here. I also want to point out this tab here for ABC, so you can have a full QWERTY keyboard if you'd like. I also love that we provided even more of the advanced buttons here. So I have my square roots, my nth root. So I have all the powers, the logarithms. I have my trig functions, and then I have my inverse trig functions here as well. So if I wanted to clear everything, let's say in my calculator, and type in something like, the sign for 30, and I can easily insert my parentheses, and I get, 0.5. I can go down here and do, the inverse trig functions as well. So just type in those numbers, add those extra lines if you'd like. So this is a really, really great tool. I'd also like to point out two other things before I have Ryan show that periodic table that we're also excited about. Ryan and I love floating, windows that we can move here. So look at this. We can grab this calculator and we can move it. Okay, so if I need to see this Google Doc, I don't want my calculator, smack in the middle of it. So I can move this around and kind of navigate that window. I can also, in the bottom corner, I can drag it and make it a little bit smaller if I want it smaller. So this is all great functionality for users. The other thing that was really cool here, Ryan, which I don't think we ever really talked about in some of our meetings, was I love how it's also out in the Chrome browser. So I want to show that I'm on this Desmos website again. Let's pull up another state. I don't want to show any favoritism towards my state here. Let's go up to, let's say, Massachusetts. And I pull up Massachusetts here, and I pull up the scientific calculator. That's going to obviously pull up the same calculator we have in our product. But what's great here is what happens when I click on EquatIO, the Chrome extension again. When I click on it, look right here. We've also added in the periodic table and scientific calculator here. So I didn't even know this, Ryan. So I thought this was pretty cool when I saw those were actually added in. So if you're just browsing out in Chrome somewhere, we've added in those two great features right within our kind of abbreviated Chrome extension here. So this is where we commonly grab that screenshot reader and our discoverability tool. Now you can pull a calculator out anywhere when you're browsing in Chrome. So you don't have to go find it, let's say, in Windows and use a calculator that's not on the test, so to speak. So really great functionality there that we can take that calculator, navigate it, move it around, and then you also have the calculator permanently in the EquatIO extension. So really, really encourage you to give that calculator a shot. Let students know, do the research on your end, go to desmos.com/testing and look and see if it's on your state test. This would really, really benefit your users throughout the school year to use the calculator that we've now integrated directly into our product. So that being said, I'm going to let Ryan take this back, and he's going to show the STEM tools from the periodic table perspective.
Thanks, Louis. Yeah, that was a really good segue, actually. So I'm going to show the periodic table in the web toolbar as well, what we like to call the web toolbar, which is pretty much anywhere that's outside of Google Docs.
Yep.
So like you said, we've now got our periodic table and our scientific calculator anywhere across the web. You just click on the EquatIO button in your Chrome browser bar, and that will drop this little small toolbar onto the page. So as you mentioned, we've been working really, really hard on our periodic table. And I mean, I remember whenever I was at high school, and we just had a periodic table up on the wall at the back of the classroom somewhere, and our teacher sort of pointed, yeah, it's, you know, you gotta go and get up off your seat and look over there. But now with technology these days, we can make it, you know, much more interactive and, you know, much easier to use and a great deal more information. So to access our periodic table, as Louis said, it's on our toolbar. Click on the periodic table icon, and we get this nice little multicolored interactive periodic table. So we've got all of their elements, their positions, their names. We can hover over it, and it'll show their name in bigger font as well. Because obviously, with a periodic table, there's so much information on it. It's really hard to sort of get it all visible up front straight away, especially for users, you know, with vision impairments and things like that too. They're going to probably struggle to read some of that small font.
Right.
It's all obviously fully keyboard accessible as well, so I can tab through the table in order using my keyboard, and I can press enter or click on an element to find out lots more information. And I really like this piece. This piece is very cool. Whenever I click on an element inside the periodic table, it goes out to Wikipedia and it grabs information about that element. So it shows you a nice little photo of what the material looks like. So we've got in there, this is sodium, it's an alkali metal, and it gives you a little breakdown of sodium itself. Obviously, we've got the details on the left-hand side, so it's electronegativity, we've got atomic mass, affinity, and so on. And on top of that, we've got a little link at the bottom here to say read more in Wikipedia. So if you click on that, that's going to bring you out to the Wikipedia page for sodium. And at this point, this is what I like to call, you can get into a Wikipedia loop. So you go from there into another element and back into Wikipedia and so on and so forth. You can spend a lot of time there. So like I said, we've worked really hard on the periodic table. There are a couple of bits of information that are missing from it, but we're always updating an equation. We're always adding to it. But we just wanted to get this out into the hands of users so, you know, they can play with it, let us know what works and what doesn't, what kind of information you think is missing from the table, and we're absolutely happy to add it in as well. We're trying to get that sort of balance between simplicity and ease of use, and also the level of detail required for it to actually, you know, be usable in a classroom setting or a learning environment. And as Louis mentioned as well, you know, you can move the periodic table around. And one of the cool things whenever you resize the periodic table is it resizes then the elements so that they fit in. And you can still hover over the top and they're still legible then at that as well. And clicking on it as well gives it that sort of semi-transparent effect. So you can read the text in behind the table as you're working as well, which I think is a very neat little feature.
Yep, that's very cool. Yeah, the only thing about shrinking it down like that is, like Ryan said, you'll still be able to see the element. It just might be a lot harder to see the atomic mass.
Yeah, I mean, I said shrink it down. I always get things bigger as well. That's the important thing for me, especially with somebody with the glasses, you know.
That's right. That's right. Yeah, but that's really good stuff. So, you know, Ryan and I showed how those windows can be, you know, shrunk, and we can, and that's cool how he selected it, and you can still see the text behind it, and there is that transparency mode sitting behind it as well. So, as Ryan said, I've already gotten some feedback on the periodic table, which I'm going to share over with our development team. You guys, and the feedback that you provide, you know, Ryan and myself, you know, help drive that roadmap. So as Ryan said, this is kind of like our first model for the periodic table, and we certainly can look at making improvements and adjustments. If there's something that you think, hey, they kind of got this wrong, just let us know. Give us feedback. Let us know how things can be improved. And as always, Ryan and I will do what we can in working with our team of developers to make this as user-friendly and as beneficial for students and teachers as possible. So those were kind of our 4 talking points today, and we actually finished right on time, Ryan. It's amazing. Usually we go over. So
yeah, I was going to say, if we didn't have all those technical hiccups, we maybe would have finished early today.
Yeah, right. I know. So yeah, sorry about the technical hiccups, but those things happen, as you guys know. Especially those in the classroom. Those technical things happen. So appreciate your patience with that. Ryan and I look forward to doing this again real soon. We got lots of great things still that we're going to be working on this summer. Hopefully just in time for back to school. Even though, hey, it's June 1st. Don't think about school right now. Enjoy your summers. Enjoy your summertime with your family and friends, and we will be back on the air very soon with you with some further development and some other things that we hope to put in our product here real soon. So with that being said, on behalf of Ryan and myself, we wish you a safe and great rest of your week. Thanks for joining today. Bye-bye.
Thanks, everyone. Bye.